Hello everyone. So in this second video, this is meant to help you out with all of the post-lab work that should go in your formal lab report for the Hydrate Lab. So once again, we have a picture here of your lab notebook. Please remember that you should be writing in a pen, right, a ballpoint pen, so that it does in fact go through to the copy page. Also make sure that you're always putting that divider between the pages so that you don't end up, pressing through 4 pages at once, because then that'll be quite a mess. So you should have already done the introduction, references, purpose, materials, procedure, and data and observations in your first video. So whether you had time to finish before the lab or not, that's what you should already have done. At this point, we're going to start with the calculation section. So if you look at your next piece in your lab report, it says that you should include the calculations. Let me remind you also that you should have all of this header filled out. So let me just quickly change my color here. And we can get this filled out. So we're still going to say that this is experiment 1. Remember, that's because this is our first one we're doing this year. And our title will still be Hydrate Lab. And you would put your date. I'm making this video on 10/11, so that's what I'm going to put there. I would put my name. You obviously would put your name. And you put your lab partner's name, whoever that was there. Okay, don't worry about the locker or desk number. You can put AP1 just as a reminder that that was the course you were doing this for, because you will share this notebook with Chem 2. So what we will do is, again, we start at the left. So remember, starting at the left, you're going to try your best to fit this, 1 block per line here. So I'm going to write calculations as my header. And now I'm going to start. I'm going to number it question 1. I'm going to indent just a little bit. I'm going to start with question 1. You should write a little bit of a reminder to yourself what that is. In your lab packet, you'll see that you already have a topic for all of these, so it makes it nice and easy. So for your first one, you're going to write mass of hydrate. And then you're going to figure out, okay, let's write sort of a generic formula. It's not a real formula, but we would want to write some information so that if someone else were to look at your lab report, they would know exactly where all these numbers come from that you are using. So if I wanted to know the mass of the starting hydrate, I just want to know the mass of the crystals. So what I would do is, if you look at your data table, we would take the mass of the evaporating dish plus the sample. And from that, we're going to subtract the mass of just the evaporating dish. So by writing just this little phrase, we're indicating to anyone who would look at your report exactly how they could determine the mass of your hydrate. So now you would actually fill in your actual numbers. So whatever you had from your data table, that in grams minus that in grams equals, and you would get your answer here for the mass of your hydrate. Okay, so that's what this should look like generically for calculation 1. Okay, then we would go to calculation 2. Skip a line or two, number that number 2. And now again, we write our header. So number 2 says mass of anhydrous residue. So remember, jot down a signal phrase. So let's think about this. The anhydrous residue, that means the dry version of your hydrate. So after you heated it, we want to know what the mass was. Now, this is a little bit easier, because it's very similar to what we just did. You measured the mass of your evaporating dish plus your anhydrous sample. So once again, all we need to do is subtract off the mass of your evaporating dish. So once again, we would write our signal phrase. So mass of dish plus anhydrous sample, or you can, word this differently if you would like, minus the evaporating dish mass. And excuse me, I'm running out of space there, so I'll squeeze that in there on the edge. But you can, of course, go on to the next line. So once again, we would then write our numbers. So this mass in grams minus this mass in grams equals, and then circle or box your final answer. So hopefully you're getting the hang of this as we walk our way through. Okay, when we get to question 3, mass of water removed. Well, we know the mass of our original hydrated sample. And we know the mass of our anhydrous residue, and as we've talked about previously, when you heat a hydrate, what happens is the water in the hydrate evaporates. So this change in mass here is due to the mass of water that was originally in your sample. So again, let's draw our header so we can, or write our header, excuse me, so we can do that. So the mass of water removed. Again, we would take the mass of the hydrate, so sort of just reusing my headers from questions 1 and 2, minus the mass of the anhydrous residue. Okay, again, this mass minus this mass equals, and then there's our final answer. Okay, so that's the first 3. All that is essentially just subtracting and thinking logically about what happened with your data. For questions 4, 5, and 6, our math is going to be slightly more involved, but we'll talk through those as well. Okay, so moving on to question 4. Question 4, it's asking for the experimental percentage of water in the hydrate. So remember, if we're talking the experimental percentage, we're using our actual data to figure out what was going on here, right? So if I want to know the percentage of water in the hydrate, that would be the mass of just the water in the hydrate over the total mass of the compound multiplied by 100. So for my setup, I would write exactly that. So I would write mass of water divided by, or you could set this up as, a more typical fraction if you'd rather, over mass of sample, so the total mass essentially, multiplied by 100. So there's my signal. Now I just write in my actual values. So the mass of the water, which we found in question 3, divided by the total mass of your sample, which we found in question 1, multiplied by 100, and then we get our mass, or not our mass, excuse me, remember that would be a percent of water in our compound. Okay, so that was our experimental mass, our experimental percentage based on our data. In question 5, you're asked to figure out the theoretical percent of water in the hydrate. Okay, so you can call it correct, you can call it theoretical, whichever you'd rather. So if we work our way through that one, this is where you don't actually need any of your data from the lab. This is where you have to think back to one of our earlier units. I believe that was in chapter 2, where you had to deal with percent composition data. So for my setup, here I would again, instead of using experimental data, use stuff from the periodic table. So I would take the molar mass, which I'm going to abbreviate MM, but you can write out the molar mass of water in my hydrate, keeping in mind that this is copper sulfate pentahydrate, right? Because all of your calculations are for the copper sulfate pentahydrate. So take into account the fact that you had 5 waters divided by the total molar mass of the compound. So that would be the molar mass of CuSO4.5H2O, and then multiplied by 100. You would then calculate those values, take my mass, grams per mole, divided by my molar mass here, multiplied by 100, and that would give us our theoretical percentage of water. In a perfect world, these two numbers would be the same. Most likely they are not. So we want to figure out what our percent error is. That would be our final question here. Now, notice that I am nearing the edge of my page. So as you near the end of your page, don't forget to fill out the bottom piece here. So for me, I would sign it or initial, whatever works for you. Today's date, again for me, that was 10/11. You don't need to worry about a witness or a TA, so you don't need to worry about the date there either, okay? But now I would move on to the next page. And again, I would need to fill out my header. So again, experiment 1, Hydrates Lab, my name, well, it would be your name, not mine, but you know. Your lab partner's name, whoever that was, the date, and this is whatever the day it is that you are doing it, and then AP1, okay? So now I'm still continuing with my calculations. I'm still slightly indented because I'm under that heading calculation still. For your percent error, so I'm gonna write my header percent error there. You should have jotted down the percent error formula earlier in your lab, but you are welcome to write it again here if you would like. So you can write your percent error formula. I'm just going to write this, but you can, of course, write it yourself. And then you would actually show your work. So you'd have your percent minus your other percent over the other percent multiplied by 100, and then again, your percent error. Remember, the lower your percent error, the better you did, okay? So that would end our calculation section. We then would go all the way back to the left, skip a couple lines, we go all the way back to the left, we put our next heading. Our next heading is error analysis. Let me rephrase here because I spelled wrong. There we go. Okay, our error analysis. So for your error analysis, what are the things you should include typically? So your error analysis should be a few sentences that explain where this percent error that you found over here, where did this come from? Because it didn't just come from, nowhere, right? Something had to have caused it. So what we need to see is in your error analysis, we're looking for a few sentences that will explain where that came from procedurally. So what do I mean by that? Procedural errors are what we are looking to include. Okay, so procedural errors are usually things that are beyond your control. So look for things beyond your control. Okay, meaning things that definitely would have affected your data. So looking back at your data table, look for things that could have affected the mass of the sample, the heating process. Think about what could have affected how much it heated, how little it heated, things like that. But for them to be beyond your control, they can't be things that you could have fixed. So for example, you can't say, my partner stinks. That is not a valid error analysis suggestion. You cannot say, we did the math wrong. That is not an acceptable solution either. You could have fixed your math, right? You are looking for things that are beyond your control. Some labs, there are a lot of things, and it's easy to say, okay, the procedure said to watch out for this, but we couldn't avoid it. There are other labs where there might only be one or two. As we work our way through the year, you're going to get better and better about thinking about which things would be valid sources of error and which would not. But just to jot down a few again as a reminder, never say anything about blaming your partner, blaming your math, because you could fix your math, blaming the balances. So we measured wrong is not a valid response. Okay, so you can never use any of those, all right? If you're having trouble, you're welcome to come see your teacher and they'll chat through this with you in advance, some potential options. A good rule of thumb is in your error analysis, try to follow it through all the way to your final calculation, meaning say something like, okay, we think this was or not we would want to speak third person here. So this could have caused our percent error because it specifically would have affected the mass of our anhydrous residue, which in turn would affect our percent error. Something like that, where you're following it from the error all the way to how it would affect your final answer, specifically your percent error. Okay, so you should probably note somewhere in there what your percent error is. But again, all we're looking for are just sort of a few sentences to sort of explain and have you think critically about what could have affected your results realistically, okay? So now moving down, that would be the whole error analysis section, okay? So moving past error analysis, the final piece we would use is our conclusion, okay? So again, don't forget, start all the way back at the left, skip a few lines in between. We write our conclusion, and now we start writing. So what should your conclusion include? First off, it should be in paragraph form, so these should be complete sentences, okay? And what we are looking for, we are looking for sort of a restatement of your purpose, and that should be pretty brief, because what we're looking for you to say is, okay, if someone were to read just your conclusion, can they get a gist of what the lab was, what you did, and what your results were? So briefly restate your purpose. Okay. Then also, we would want you to say sort of, what did you accomplish, So sort of state your results, because your results will indicate whether or not you met the purpose. okay? That would follow that you should then sort of note your percent error, and again, sort of summarize where that came from. So in this lab, that would look something like we were able to determine the percentage of water in a hydrate, which allowed us to study the properties of different ionic hydrates. Even though we determined the percent of water in the copper 2 sulfate to be, let's say, like 30%, we had a percent error of, let's say, 5%. So that 5% error could have originated from X, Y, or Z and restated it, okay? Other labs may include different things, but sort of for this first lab, this is the generic format we're looking for, okay? So restate your purpose, explain what your results were, summarize what you did essentially. Don't rewrite the procedure, just sort of summarize how what you did met this purpose, and then note your percent error once again, okay? You may use as many pages as you need in your lab report, so this should not all fit on 1 or 2 pages. Just because it did in my video does not mean it should for you. It will be longer. When you are done, you will rip out the carbon copy pages or the white pages, depending on what your teacher tells you, but the moral of the story is one set will stay in your report, in your notebook, and then the other set will be turned in for a grade, okay? This is our first formal lab, but we will do around 7 others during the year, so the more you do these, the better you will get. I hope this video was helpful. Hi again. I realized that I had forgotten to tell you about one other part of your lab report that would not be in a traditional lab report in a collegiate lab usually. However, for ours they will. So the final section you need to add to your lab report is you will add a section on the post-lab questions, okay? So just like with the other ones, we will write our heading, so post-lab questions, underline that, indent a little bit, and start with question 1. So it is not required that you write a heading, but it may be useful so you know where these are coming from. But your other option is you can sort of reflect the question in your answer. But try your best to answer these with complete sentences. So you'll just jot down your answer to number 1, then skip a line, do number 2, skip a line number 3, etc. When you get to the one where you have to do naming and formula writing, it is perfectly fine if you would like to just include the table that's in your notes, again using a ruler so it's nice and neat. So if you would like to just include that, where it has name and formula, I think I'm missing a row here, but you get the idea. If you would like to just do that for number 4, you're welcome to, and then you can just fill in your answers as needed, okay? So that's the final section you'll need in your lab report. There is the post-lab section. Again, you would fill this whole header out as you have in your previous pages, okay? So now the video is all the way done, so my apologies. You need that one last section after your conclusion with the post-lab questions. Good luck.